Hi, and welcome to this video where I'll give a quick overview of how we here in 2026 measure AI intelligence. And quickly before we start, this AI intelligence comes with like kind of an asterisk because AI intelligence, in my opinion, is definitely not the same as human intelligence, but intelligence is a good word for measuring how well AI can generalize tasks and generalize performance across tasks. So I personally use AI intelligence as the word for like how generally good a model is. And of course, in the perfect world, we all have our private and personal use case benchmarks, which we can try all new models on to see how well they fit our specific use case. But in practice, we need some pillars of AI intelligence measuring so we can get a quick understanding of how well a model performs when a new model comes out. In my opinion, artificial analysis is the go-to place for getting a general overview of model performance. They have the intelligence index, which is a combination of 10 different benchmarks, which over in general try to cover as much as what AI is currently used to do. And on this benchmarks right now, on the new 4.01, we have ChatGPT 5.2 extra high here with the leading score, and Claude 4.5 here with the next largest score. And I think this is a very good place if you just need a quick overview. A new model comes out, you want to see how it performs and the cost, then artificial analysis is great. The benchmarks that it uses are these 10 benchmarks here. They are sorted into the 4 categories and is weighted accordingly between agents, coding, general, and scientific reasoning. I think this, with a heavy emphasis on coding, which might not be the best for everyone, but coding is right now still one of the greatest way we are using large language models. I want to deep dive into some of the, I think, most important benchmarks on this. The first one here is the GDP val, which try to measure how well AI performs and large language models perform at knowledge work. I have an example task down here. Here this is in the finance sector and in the role of customer service representative. Here it gets some context, and then the LLM is asked within an agentic environment to create a slide deck containing an agenda and propose a summary result. And it can, in this agentic environment, freely read this file here, which probably gives some more context on this. And then the agent with the specific LLM inside comes up with an answer, and so does all other LLMs. And then each of these answers are then evaluated against each other, one-on-one, and then a judge then decides between answer A and answer B without knowing which answer comes from which model. And from this we can create these ELO benchmarks, which means that they are dynamic, so newer models would then lower the performance of older models, but this works quite well. And here you can see that GPT 5.2 is the highest, and again Claude Opus with 4.5 with the next highest. And actually here we see that Gemini 3 Pro actually scores quite low compared to like how well the model performance is perceived on that model. Now, the very interesting is the artificial analysis omniscient index. This is where we try to this benchmarks we measure model performance on hallucinations, and it has 6,000 questions across many topics. And the cool thing about this, I think, is that it's heavily penalized for wrong answers or incomplete answers. and the models here are allowed to omit an answer. So we also test whether models know when they don't know the answer. And we can see here from a score from 100 to minus 100, we only have quite a few models which actually perform better than 0, meaning that they answer more correctly on these answers than they answer wrong. With Gemini 3 Pro as the highest performer. This tells us generally that LLMs as a basis for just answering questions is quite a bad idea, and we should look to agentic environments for that. But I think the fact that we can measure when a model actually don't know the answer is quite useful. Another great place to look at model performance is on LM Arena. Here all answers and all evaluations are done by real humans. So you know that it's not just benchmarks, it is real humans evaluating these models blindly. And here we see quite a large push-out victory by Gemini 3 Pro, and with Grok actually scoring number 2 on the text category. Then we see on the web dev category, we see quite similar-ish results as the artificial analysis results, with Claude Opus 4.5 and Gemini 4.2 scoring quite high. And the way that these are evaluated is that a prompt is given. You can either give it yourself or get general prompts, and then you vote on the best answer between assistant B and assistant A. Another great thing about this LM Arena is that it has this creative writing category, which is something I personally find very useful, because many of the other benchmarks are quite technical based. So this gives a overview of which is the most creative model and can formulate itself greatly, of course only in English, but we still get this, we still get here a large, heavy victory for Gemini 3 Pro, which means that, as according to right now, this might be the very best model to help you write your LinkedIn post and so on. SWE-bench is software engineering benchmark, is a very, very heavily used benchmark when it comes to evaluating which models perform the best on software engineering tasks. And here we have, I would say, quite an equal victory for Claude 4.5 Opus and Gemini 3 Pro on the software engineering benchmark. And where this differentiates itself from the other earlier benchmarks on coding we've seen is that the goal for the LLMs here is to fix real bugs and implementing new features, but not one-shotting it, but by iterating. So it gets some code, and then it should make a diff file or patch file, and then that patch file is evaluated for how well this new version of the code performs in terms of passing the tests. And this more closely mimics the way we actually do software engineering and the way that agentic coding works. So it implements some, and then it iterates over that and iterates. So this benchmarks quite well, and then the measures this quite well. And also another interesting fact, I think, about this is that the benchmark is just really well constructed. It has been around for quite some time, and we haven't fully saturated it yet, because some of the tasks on this benchmarks are extremely hard, and that just goes to show how well designed it is. So we can keep using it until we push up in the high 90s, I think, for model performance. Then we have the ARC AGI benchmarks. Here we have the ARC AGI 2, where we are right now on the 50 to 55% with the GPT model, scoring quite higher than the others. The philosophy behind these ARC AGI benchmarks is that it tries to find something which is extremely easy for humans, which can be learned patterns and then learning patterns and then reproducing those patterns, which can actually be very hard for LLMs to do. So an example here is on an ARC AGI 2 task. We have this example input, and then this is the example output. Down here we have example input 2 and then output 2. So you can see the pattern quite easily is that whenever we have an X in the pattern, then we need to mark it blue. And then the LLM then gets this, and then it has to fill out this on its own. And this turns out to be extremely hard for LLMs, actually, to learn on the fly in context. It is very good at reproducing what is in its training data, but not that good at learning a new problem on the fly and then completing that. We also have the ARC AGI3, which tries to even further measure intelligence by measuring fast learning, fast adaptation, and novel problem solving, which actually turns out to be the perfect description of how simple video games work. So this is an example of the ARC AGI3. It gets to know nothing about this game, then it gets let loose controls, and then it gets to see how it is affected. So the goal of this game is to go over the mark spot, so this thing here changes, and then you can go over that and win a level. Then each of these games has 10 levels, and the rules continue is the same across the levels. So you might see, okay, how well can this perform? How close it is to humans already? And we have the answers here, which is not even close. On this specific game, the frontier AI doesn't even complete the first level, which you can see how easy it is. You might actually stumble upon it randomly, but they are just so bad at exploration and learning from that exploration. The average human, you can see here, this amount of steps they take, complete all 10 levels within 200 to 300 games. The theoretical best here is only 150, but not even the best LLM complete the first level consistently. I also like to take this time, the ending of this video, to talk about the honorable mention of like other, I would say, very fun but not quite as generalistic benchmark. We have the Claude Plays Pokemon, also called PokeBench, which you let an agentic framework interact with the old Game Boy game Pokemon and then see how far it can come. And then now that we have completed it, we see how few steps it needs to take and how fast it can complete Pokemon. We also have Vending Bench, which is a virtual environment where a LLM in an agentic environment needs to play the role of controlling a vending machine. So it each day has to make investments on new vending machine, how to stock up the vending machine, set prices, and then also react to unexpected events. This tries to mimic like how well can a LLM actually perform in a business context. Then we have GeoBench, which is a benchmark based on the popular game GeoGuessr, where an LLM is given a picture of a place in the world from Google Maps, and then it has to guess how well where this is. And this gives like should give a general perspective on like how much world knowledge this model has and how well it understands how it can see these images and get clues on different things on the images. But this was all for today, and thank you for watching this video to the end.